Today I'm going to talk about how ZkVerify is going to market. This is going to be for a general audience. I'm going to talk about what the opportunity in the space is for the zero-knowledge proof verifications, and it's for a general audience. I'm Rolf Versluis. I'm the Director of Business Development at Horizon Labs. Our team is going out and talking to all sorts of other projects about integrating ZkVerify into their ecosystem. So we're going to go over why ZK now, what's changed that it's all of a sudden so exciting in this space, what ZkVerify does, and what type of applications and systems it enables. So I'll draw a nice little diagram and step y'all through this. How it works with other ecosystems. So pretty straightforward, designed to be composable and modular and work with all sorts of other ecosystems out there. And I'll give examples of what we're doing regarding that. And then how the ZkVerify team is going to market. So we're going to talk about specific things that we're doing, the opportunity space within zero-knowledge proofs in the short term and the long term, and how we're looking to address it. One thing I can tell you is I'm not going to spend this entire time talking about ZK rollups and aggregation. This is going to be about completely different stuff. Before I explain how ZkVerify works, I'm going to talk about just basics of what you can do with the zero-knowledge proof. First of all, I don't really fully understand this because it's advanced cryptographic math. So I know on Horizon Labs, we got a great team of cryptographers and software developers that can implement this cryptography into reliable software. I just have to go out and talk to people about it. But the way that I understand it is we have public inputs, we have a series of computation, and then we have a result of those computations. Now this information is fed into a ZK proof creation algorithm, and that's run on some kind of computing system. So basically, this goes through and uses the cryptography of the public inputs, the computation, and the results, and creates a zero-knowledge proof. Now, creating the proof is great because you can prove that these computations were done correctly without sharing the computations. So all you have to do is share the public input and the results and the zero-knowledge proof. So how do we verify this? Okay, well, the verification, which is just as important as the proof creation, is done by having the inputs to the computation, the results to the computation, and the proof all sent to the verifier. And this math is set up so that a lot of the calculation, a lot of the work gets done in the ZK proof creation, and the ZK proof verification doesn't take as much computation, so it can be done quickly. So anyway, you get these three inputs to it, and you get an answer. Either it verifies that the ZK proof was correct, and it proves that these computations are correct as a base of these results, or it's false. So that's big picture what you can do. So any type of system where you want to prove that a computation was done properly, or that the underlying information is valid, lends itself to ZK proofs. And longer term, this is going to allow Web 2 applications to work with each other over public Web 3 because ZK proofs are able to prove the inputs from the Web 2 to the Web 3 applications and also prove that the computations were done. We can talk a little bit more about that in detail, but the big idea is that we're going to be able to come up with entirely new ways of communicating, doing finance, and doing all sorts of other types of transactional activity, or even just activity between people and groups of people using cryptography to verify that things are done properly. This is how the ZkVerify system basically works. A ZK proof gets generated. We talked about that on the previous board. Then it gets sent to the proof input part of the ZkVerify system. ZkVerify is everything in this green box. The proof goes to the input. That's with an RPC. And it's got a bunch of information about the proof and the public inputs and things like that. Immediately, it gets sent to the first validator. This is a proof of stake blockchain. There's validators. The proof verification is done by the validators. An answer is immediately returned on that, that RPC communication as to whether the proof is verified or not. This happens in milliseconds. So this is the first validation. Then, once 2 of 3 validators verifies the proof positively, it gets put into a block on the blockchain. And this is a substrate-based blockchain. These are 6-second blocks. So you can look it up on the Block Explorer or use some kind of RPC interface to get the proof transaction number and look up the status of that. So that happens in about 6 seconds. From there, if desired, it goes to an attestation creation. And so this takes basically about 100 of the proof, the successful proof verifications together, puts it into a Merkle tree, and sends it through a bridge, the destination blockchain. Right now we have 3 destination blockchains: the Ethereum testnet, the Horizon Eon testnet, and the ApeChain testnet. ZkVerify is not an EVM. It only does 2 things. It manages the new ZkVerify token that's going to have a token generation event when we go to mainnet, and it does proof verifications. So there's no contention for other services. There's not going to be NFT launches or decentralized exchanges or anything other than that. There's just going to be highly optimized verifiers written in Rust and doing proof verification. This should have the performance, it should have the best performance of any type of verification system out there because it's not doing anything other than verification. And it should keep the costs really low over the long term. After the attestation, so the bridge is what makes this composable. And right now, from a business development standpoint, we're talking to a few different bridge providers that are very interested in working with us. They have experience working with Ethereum virtual machines, working with substrate blockchains like Polkadot and Kusama. And so we're confident we're going to have at least one bridge going pretty soon. So that's exciting. So, okay, this is pretty much how ZkVerify works. But what does this unlock? So the thing is, we can have verifiers written for any type of ZK proof. And that makes a big difference compared to how ZK is used today. So let's talk about the exact problem we're solving, what it addresses, and how this unlocks the last 7 years of ZK technology research to be able to put into production. So if there's all these kinds of ZK proofs and we can do all these great things with them, why hasn't that been done already? Well, it has to do with how ZK proof verification was implemented in Ethereum. I believe this was back in 2017, some precompiles, so very rapid ways of doing the proof verification based on the BN254 elliptic curve were put into Ethereum. People wrote some ZK proofs that took advantage of this elliptic curve. More common ones that you might have heard of are Groth16 and Halo 2. And these are good proofs. They take a lot of computation, but they're very small and they're very straightforward to verify. So that's optimized for working on Ethereum. There's been a lot of research in new types of ZK proofs over the last 7 years. So there's new types of curves like the BN12381. There's new types of zero-knowledge proofs like Starks, which don't use an elliptic curve. And kind of a side note, elliptic curves are not quantum safe, so if we ever get quantum computers that can crack elliptic curves, those ZK proofs are at risk. And Starks are quantum safe because they use hash functions. FRI, I forget what that stands for, but that's a different type of ZK proof. And you might have heard of different names like Circle Starks or Binius or Minocchio. I'm just lumping these together into new types of ZK proofs. And some of these new types of ZK proofs, they got all sorts of different names. But these are the ones that can be have the flexibility to be verified on many different types of computing machines, like mobile phones. They can do trade-offs between size and time. So, for example, a Plonky 2 is an FRI type proof that you have the choice of either generating a fast proof very quickly, but it's a little bit large, or you can take a longer time to generate the proof and it makes it small. So it's kind of a best of both worlds type proof. So anyway, all the new ZK proofs that are being generated are these new types, but then in order to verify them on Ethereum or an Ethereum virtual machine, it needs to be wrapped. So you can take one proof and use it as the input to another proof, and I call that wrapping. New ZK proofs have to be wrapped in an old proof. So as an example, you can go look at the benchmark information for RISC-0 on their website, and they'll generate their Stark proof in about 2.5 seconds on a PC with a graphics card. And then that Stark proof could be sent to ZkVerify directly, and we'd verify it. We'd want to do that. In order to be verified on Ethereum or an Ethereum virtual machine, it has to then be wrapped in Groth16. So that wrapping takes another 15 seconds of computation. It also has the limit that has to be done on an x86 machine. It can't be done on an ARM. So it can't be done on a Mac. It can't be done on a mobile device, that kind of thing. So you'd have to use a prover network, or you'd have to have a x86 laptop to be able to do this. So that really limits it. And there's a big difference between generating a proof in 2.5 seconds of computation and 17 seconds. So that's why the limitation of usable zero-knowledge proofs has kind of been stuck for the last 7 years. And we unstick it with ZkVerify. So we're like, we want every single proof out there to be able to send their proofs directly to ZkVerify for us to verify them. And that's how we enable all these new types of applications by addressing the proof verification aspect of it. So let's go on and talk about some of these applications and where we're working to get these applications developed. So where do we think the best future use cases are going to come from? Well, there's been a lot of people that have been working to develop ZK applications in the blockchain space over the last few years. You can look in GitHub and see all the different projects that are there. Unfortunately, most of them seem to have been abandoned. It appears that very few of them were able to do the ZK proof and verification fast enough at a good enough price to make it a viable product. So given that we have these new ways of verifying, these new types of proof that can be done really fast, very inexpensively, I think there's going to be a lot of new applications that are going to be launching using ZK proofs. So games, I think, are going to be first. So you can do Fog of War. There's simple demo games like Battleship or Sudoku and proving that you got the solution, or Wordle and proving that you got the solution. Those are great starting points. But other types of, there's many types of games being developed to run on blockchain, adding the capability to have provable things that other players can't see are very useful. Then there's card games. So imagine being able to shuffle a deck of cards, having a very specific order of the cards, as using zero-knowledge proofs that nobody can see what the card order is. And then being able to deal the cards, individual players that are playing each other can see their own cards, but nobody else's. So this way you can have provably fair, blockchain-based, person-to-person games that use zero-knowledge proofs, and of course, provably random inputs so that the decks are shuffled randomly. And this will open up types of games and things like that that everybody can understand and see the use case for. And if the ZK apps are generated in less than a second on a mobile phone and then verified very inexpensively, and everything happens in less than 8-9 seconds for each ZK event, that's wonderful. And then if you want to take the proof all the way through to the blockchain, where things are being settled on at the end of the game when it comes time to determine who's the winner and award the points, then you can do that too. There's a lot of flexibility in here. There's a lot of segmentation in the ZK proof marketplace. Being able to do an online opinion poll or voting for the prime minister of a country are two different levels of ZK use cases. So in one of them, you might want to make sure that you go through fully decentralized and secure and provably correct type thing. In others, just quick and fast ZK verification with follow-on before any awarding of points is done is a way to do it. Anyway, there's different segmentations that are done in the ZK space, is my point. So identity, person-to-person identity, decentralized identity, verifiable credentials. Verifiable credentials are going to be the things that replace contracts that use ink, paper, government stamps. This is the type of system we're going to be using that runs the world's economy, the person-to-person interactions, the business interactions, the financial interactions. They're all going to be using some element of ZK proof to be able to do selective disclosure of information and proving that things were done properly. Voting, opinion polls. Imagine being able to cast your vote anonymously and then verify that your vote was counted on the blockchain without anybody being able to then find your financial history or things like that. And then the big thing is interoperability between different Web 2 applications going over the public blockchain. The ZK technology is going to be used to prove that computations were done or to selectively disclose things. The example I use for this is, imagine that you want to have that you're an online seller and you have great seller reputation on eBay, you have great seller reputation on Facebook, and you want to start selling on TikTok Shop. And you want to take all those reputations that you've developed over the years on these siloed Web 2 apps and bring them together in one meta seller reputation app in public blockchain. You'd be able to use zero-knowledge proofs to prove that you have those seller ratings and that they all apply to your meta seller rating that you can then tell people about on TikTok Shop. So, and then there's going to be new and unknown things. A recent hackathon, a ZK hack in Montreal, a developer created an application using RISC-0 and ZkVerify that basically said, okay, in order to join this Telegram group, you have to prove that you own a certain amount of this token. Or it could be you could own a certain NFT or something like that. And so it, without disclosing what the address is, you still are able to prove that you own the token or NFT, and then you're able to join that Telegram group. That doesn't even use another blockchain, so it doesn't need the attestation aspect of it. It just needed a place to be able to verify that the proof was done properly. Okay, so who is ZkVerify working with? Well, when I say who's ZkVerify working with, that means, so the ZkVerify team at Horizon Labs right now, business development team, developer relations, so community relations, marketing, and then the internal developers that are developing our systems. So this team, you're going to see us all over the place. We're working with ZK Virtual Machine and ZK coprocessor organizations. We're carrying the message that you don't need to wrap your proofs in GROS16 to send them to an EVM. You can send them directly to us. Less computation and much faster and less expensive verification. ZK proving services. There's a lot of proving services. Even if you have faster computation, there's still sometimes millions and millions of transactions that need to be verified. And instead of doing that on your machine, your own personal machine, you go to a ZK proving system that will use large servers that have graphics cards or ASICs or things like that. We're talking with those organizations to get them to send proofs directly to ZkVerify as a way to offer the service to their clients of lower computation cost and less expensive verification. App developers. We're trying to reach app developers everywhere, carrying the message that you can use all the cool new ZK proofs that you want to, and you can verify inexpensively on our blockchain. So we're going to ZK-focused hacking competitions, Ethereum-focused hacking competitions, and then we're going to be doing a lot more. We're working with developer tools. So there's domain-specific languages. There's many different ways of generating ZK proofs. The ZK virtual machines and ZK coprocessors are some of them. There's domain-specific languages. There's no-code tools like Sindri. So we're working to get our ZkVerify system integrated into those types of systems as well. Now, how are we going to reach the developers? So hackathons, workshops, online workshops. There's a great meta school program running right now for developers for ZkVerify. You should go take part in it. We're going to engage with other ecosystems. We're already engaging with the Horizon and the 8-chain ecosystem, and we're putting in grants to engage with other ecosystems as well. And these are L1s, L2s, L3s. We want to work with all the ecosystems out there. We don't want to just deploy our smart contract, though. We want to work together with these ecosystems to work with their developer relations team to go show their developers how to write applications to use ZkVerify and take advantage of all this new stuff. And then to go work with their users to get excited about using these applications and want to expand our ZkVerify developer and users in conjunction with these other ecosystems. So we're going to be doing a lot of that. Grants and bounties. So ZkVerify is going to have grants and bounties for developing applications and verifiers. And then, of course, we're going to have an incentivized testnet. We're going to be doing our token launch when we go to mainnet. And we're running a testnet right now. Very soon, we're launching an incentivized testnet. And so this is where people and projects will be able to accrue points by doing specific types of things. So the first types of things is we're looking for people to deploy ZK apps that use ZkVerify. And we're looking for people to write verifiers and submit them to be done as part of our verifier palette. So a lot of exciting things going on. We're right in the middle of it right now. The development of the ZkVerify system itself is going well, and we are really facing outward and working to carry the message to the developers and users and teams out there that there's a new day with new opportunities in ZK, and all these types of applications are now possible. Work with us as we help build the new world. Thanks.